So unit 4 involves a lot of sort of heavy material. So I split it into two. We're going to do a 4A and a 4B. I do that to kind of help you out. Okay. So 4A is particle motion. As a heads up, we call it particle motion, but a particle could be anything with movement. So a car, a hot air balloon, a boat, a person, an elephant. Do you understand what I'm saying? A particle is not like a dust speck or like an atom or something. Your particle is just the thing that is moving. Okay. So for this one, our particle is going to be a racer. You can pretend they're in a car. You can pretend they're on foot. They're running. There's not really numbers here. So we're just going to kind of look at this and interpret what's going on. So, whoops, did not mean to click that. This is time. This is their speed. Use your common sense. Let's see. And I'm looking for things like A, B, C, D, E, F, G here. Okay. When is the racer speeding up? There are actually two intervals where this person is speeding up. What do you think? B and F. Very good job. Where the speed is going up. When, again, looking for a letter here, is the racer stopped? E. Why E? They're at 0. No speed. Good. When is the racer going at a slow, steady speed? So steady and like a slower amount. G. Good. Do you see how constant speed there? I would say G just because it said slow. So like A and C are faster than G, so I would pick G for that one. Again, there's no numbers here, so we don't know exactly what any of it really is, but I would pick G for that one. What is happening at D? Slowing down. Good job. What is happening at F? Speeding up. And what is happening at C? Constant speed, but we would say a constant, like if we call G a constant slow speed, we would maybe say this is a constant fast speed. Again, without numbers labeled here, but faster than G at any rate. So a constant fast speed. We don't have to actually write anything for this, but I want us to talk it out. You come up with a story of what may have happened. What is going on? Anyone have any creativity and want to come up with something? Oh, we're saying he's in a car. So he's going along and he sees a deer and so he speeds up. Okay, well, sure. He sped up.
He's getting a little excited.
Okay, this is working. I'm getting what I wanted out of you. Okay, but good, but you're thinking about it, you're being active. Oh, he's hunting the deer. Okay, so in the car. Cool. All right, then what happened? Stay with it. Then what happened? He's chasing it at a constant speed.
Then he hits it.
Oh, he hits it.
So he has to stop to pick it up.
Okay, you guys did what I asked you to do. Good job. He hits it, so he stops.
Puts it in his trunk and then starts speeding off.
And then he starts speeding off and then he just is going about his day again.
Yeah.
Good. Good job, guys. You interacted with the material. You did exactly what I wanted to do. Do you see how you laughed? You can only laugh about it if you truly understand it. If you don't understand what's going on, it won't be funny to you. Good job. That's what I want you to do. Keep it up. All right. Exactly what you need to do. And I liked your story. I'll see what I get out of my other class on that one. But I liked that. That was good. All right. Position is written S of T. I'm not really sure why it's not P, but it's S. Oh, and has anyone taken physics or is currently in physics? You are about ready to learn a whole bunch of things that you already know, which is fantastic. This is the overlap with physics unit. But we only do the math part of the physics.
That was the worst part of it.
We don't do like the friction and we just do the math part of it. All right. So position, that is just where the particle is. And so an example would be feet or meters or yards or miles or whatever have you, but it's just where it is. And again, the particle could be a boat or a person or a car. It's the thing that has motion.
Or the deer getting hit.
Or the deer. All right, velocity is V of t. That makes sense. That is S prime, your first derivative. That should make sense because it's a rate, something per something else. So this is the rate of change. So an example of units would be something like feet per second, miles per hour, it's something per something else. So if your velocity is positive, that means your particle is moving, I'm going to say to the right, but it depends on the context of the problem. It could also be moving forwards, or if you have an airplane, it could be moving upwards in the positive direction, though. Do you get what I'm saying? Forwards or upwards to the right, okay? If your velocity equals 0, that means you are at rest. That means not moving. That was in the graph that we just did, that part E, that part where we were stopped, where we hit the deer. And if your velocity is negative, I'm going to write on here moving left, but again, it depends on the context of the problem. You could be moving backwards or downwards. Like if you jumped out of an airplane, you know, you'd be moving downwards, you know, whatever. You have to read the problem and find out what's going on, but in the negative direction. That all usually goes well. Acceleration is where things get more complicated, right? Acceleration is a of t. It is the derivative of velocity, which means it is the second derivative of position. If you're like, how far does this go? We only go to a second derivative. So it is the rate of change. So we would say the rate is increasing or the rate is decreasing. What's an example of units? I'm gonna ask all my physics people. So we had feet per second. When you do a rate of a rate, does anyone know? It's feet per second. So we usually write feet per second squared. And I'm sorry, I ran into the side of the paper there, but you can write feet per second if you want to. I prefer writing the squared because it's shorter. And I'm going to do the same thing with acceleration that I did with velocity, with positive, 0, and negative. So if your acceleration is positive, it does not mean that you're moving forward necessarily. It means you are being pulled, and I'm going to write to the right, but pulled forwards or pulled upwards. The pull is in the positive direction. Doesn't mean you're necessarily moving that way. It just means you're getting pulled that way. If your acceleration is 0, that doesn't mean you're stopped. It means your rate is constant. That is like cruise control, okay? So that is a constant velocity. So you are moving, but your rate isn't changing. And if your acceleration is negative, you're being pulled, and I'm going to write on here to the left, but downwards or in the negative direction. Doesn't mean you're moving backwards. Here's the example I always use. You are in your car, you are driving down 360, you are going forwards. What kind of velocity do you have if you're going forwards? Positive velocity, moving forwards. You see a red light and you hit the brakes. Do you immediately start going backwards? I hope not. That would be some whiplash and your car is having a problem, okay? You still have positive velocity. When you hit the brakes, you now have negative acceleration. You have positive velocity. You're still going forwards. You have negative acceleration. You're being pulled in the negative direction. Do you understand what I'm saying there? And that's why you start slowing down. That brings us to speed. Speed is the absolute value of velocity. Velocity is directional, positive and negative. Speed is only positive. When you get in your car and you look at that speedometer, if you go in reverse, it doesn't give you a negative speed, okay? It's the absolute value of velocity. You are speeding up if your velocity and acceleration are the same sign. Same sign. If you are going forwards in your car, you have positive velocity. If you're pressing on the gas pedal, you have positive acceleration, and that's why you would speed up. But it works the same thing with negatives. If you jump out of an airplane, which I don't recommend, before you pull the parachute, you have negative velocity because you're going downwards. Gravity is also pulling you downwards. So you are speeding up in the negative direction. You're speeding up towards the ground. You understand what I'm saying? Both negative is also speeding up, okay? Slowing down is when your velocity and acceleration are opposite signs. That's when they disagree with you. That's the example I just gave of if you're going forwards down the road, you have positive velocity. If you hit the brakes, you have negative acceleration. When one of them's positive and the other one's negative, you start slowing down to that red light like I was talking about. This is making sense? And those of you in physics, is this like stuff you've heard before? Like, sort of. Usually I get a lot of people that are like, oh, I really like this because I've learned it already. All right, so we'll see how many of these we get through. I'll do as many as I can. So suppose a particle is moving along the line. We were given position. My question always with this unit, remember how last unit it was what rule do we need? For this one, it's what did they give us? Because sometimes they give you position and sometimes they give you velocity. And very rarely they give you acceleration. But you always go, what did they give us? What did they give us? Position, okay? Seconds and feet. Usually I circle those. Make sure you know what's going on. And usually it's seconds and feet, but you have to be careful because if you write feet per second and it's like meters per second, then it's going to be wrong. All right, find velocity and acceleration functions. Those are just your first and second derivatives. It's going to be the easiest derivative you take all day. All right, what is your derivative of this thing? 3t squared minus 3. Hey, Ms. Cole, I'd like to change them to x's. Fine, just be consistent. They won't take off for that. That's totally cool. But t is for times. That's why we do that. All right, acceleration is going to be the derivative of that. So 6t. Good job. That's all he asked for. So that's all we're going to do. Letter B, when is the particle at rest? That means what is 0? Velocity is 0. Good. So we're going to take that velocity equation that we just found, set it equal to 0, and then do some algebra. So what would you do to both sides there? Add 3. Divide by 3. Square root time 1 second. Technically, the square root of 1 is positive and negative 1. We just don't have negative time. Just throwing that out there in case you need to put a plus minus somewhere. All right, so let's fill in the chart. Let's do our position. We're going to plug 0, 1, and 2 into position. I hope you don't view this as a waste of time. I feel like going through this process helps people visualize what's actually happening here so that when we get to some other problems and it's a bit more abstract, you can kind of think of it this way. So if you plug in 0 to position, this one right here, what do you get? 2. So we start at 2. If you plug in 1, I think it's 0, right? And if you plug in 2, it'd be 8 minus 6 is 2 plus 2 is 4. So before I fill in the rest of the chart, let's come over here and make our number line so we can see what's going on. Because I think visualizing it helps a whole lot. And then when you get to a really abstract problem and it's not something you can really visualize, you can kind of fall back on this. Your particle can be anything you want. If you want to draw a little car or a little stick figure person or whatever you want, that's fine. I'm going to draw a circle because I don't have the art skills for that, right? But we start at 2. Do you see that? Wherever 2 is, that's where we started. We move to 0, so like that. And then we move to 4. So you can see the motion happening. So we go from 2 to 0 and then turn around, go from 0 to 4. In order to turn around, you have to stop. There's no such thing as a U-turn here. If you want to go the other direction, you have to stop, which is important to know. All right, so let's plug in our velocity. We're going to plug 0, 1, and 2 into this velocity equation right here. If you plug in 0, what do you get? Oh my gosh, it's negative. Why does that make sense that it's negative? Going to the left. If you plug in 1, you get 0. Why does that make sense? You stopped so that you could turn around. And if you plug in 2, what is that, 9? Oh my gosh, that's positive. Why does that make sense? Well, going to the right. I know that word, like acceleration throws everybody off. I think because we use the word like accelerator for the gas pedal in a car, that like it's not, it's a, I mean, it is an accelerator, but it's not a perfect analogy. All right, so let's plug into acceleration. If you plug in 0, you're going to get 0. Why does that make sense? Yeah, you didn't have any motion to start with. All right. If you plug in 1, you get 6. That is positive. But Ms. Cole, we're moving to the left. You're being pulled to the right. So look, We're moving to the left. It's negative velocity, but we have positive acceleration, which means that we are, if they are opposite signs, what does that mean? Slowing down. Why does that make sense that during this portion we would be slowing down? Because then you stop. All right. If you plug in 2 to this, you get 12. That's positive. So we're going to the right again, but I don't want to tell you what the answer is. We're going to write it right here. Write a description of the motion of the particle. So we are moving left and slowing down, which makes sense because then we stop. So we move to the left, we're slowing down, come to a stop, and then what happens next? I stopped myself from saying it before because I wanted to ask you guys. Then we are moving right, and why are we speeding up? That is correct. But remember, it comes down to both of them. You have to look at both velocity and acceleration. Why are we speeding up? They're both positive. Good, perfect. So then we're moving right and speeding up. Same sign. You can't just look at acceleration. That is the most common mistake. Speeding up and slowing down, you need to look at them both. All right. I'm going to go ahead and tell you the answer to this one and then ask you how I got it. What is the total distance traveled in the first 2 seconds? The answer is 6 feet. How did I get that? Yeah, so look, it would be, how far did we go? 2 plus 4 equals 6. I will not have time to do all of them, so I'm thinking about which ones I want to skip. I think we'll just do the next page, and then I can use the other pages to warm up for next time. We'll do 2 and 3, because I want to do one with a graph, and I want to do one with a calculator. All right, the graph to the right shows what? What were we given? Velocity. That's what you always want to start with. What did they give you? All right, so that is a velocity graph. At what time is the speed the greatest? This is not a speed graph. It's velocity. Speed is the absolute value of velocity, so it's a little bit tricky. When is the speed the greatest? That time when? I'm looking for just one number. 6 would be right here. That's not the greatest. Why is it 8? The absolute value that of -6 would be +6. That would be the highest one. Oh, is that why you said 6? Sorry. Okay. Let me clarify. No, perfect. Now we're communicating. Do you see that? Then I can clarify stuff. It asks for the time. So the time is the X number. Follow-up question. What is the speed at that time? It would be 6. Okay, cool. Perfect. Exactly what I want. Now, why did I not write seconds? Yeah, they don't know. They didn't give you units. If they don't give you units, do not invent them. Just put nothing. Sometimes they do that. Time 8. And you know what? I'm going to write that. Thank you for saying that. Speed at time 8 is 6. The speed is 6, whatever's per whatever. All right, letter B. At which of these times, so it's kind of like multiple choice, is the acceleration the greatest? This is not the graph of acceleration. It's the graph of velocity. How do you get from velocity to acceleration? And derivative means perfect. All right, so let's do acceleration at 2. At 2, you have to watch me point to it. That's right here. What is the slope of my tangent line? 0. Do A of 6. We're just going to find them all and see which one's the biggest. Here's 6. What is the slope of this piece of the line? Here's 6. Just regular old algebra 1. Negative. Yeah, I think it goes down 3 over 2. -3/2. And then at 9, which is right here, what is the slope of this portion? Is it up 3 over 1? 3. All right, so at which time, 2, 6, or 9 is the acceleration the greatest? 9. You do not need to explain your answer because you wrote out what all the choices were. I mean, what would you write? 3 is bigger than the other ones? This counts as an explanation. Over what time intervals? An interval involves two numbers. It's from here to here. It's always hilarious to me when I say, what's the interval? And someone's like 3. I'm like, I'm gonna need another number there. Over what time intervals is the particle moving to the left? Explain your answer. I'm going to tell you the answer. I want you to do the explaining. It would be from time 4 to time 10. So 4 to 10, because why? Why did I pick what's negative? Velocity. Because velocity is negative there. You always want to cite your source, which would be position, velocity, or acceleration. Those are the things that you want to cite. Over what time intervals is the speed decreasing? There's 2 of them. I'm going to give you one and see if you can come up with the other. The first one is from 2 to 4. There is a second one, though. I want to see if anybody can come up with a second one. From 2 to 4 is one of them. Because I want to see if, like, by instinct, maybe anyone can get it, and then I'll explain it. I just want you to think about it first before I just, like, spoon feed you the answer. It is 8 to 10. Good job. 2 to 4 and 8 to 10. Speed decreasing is where velocity and acceleration are opposite signs. They have to disagree with each other in order for you to be slowing down. Do you see how for this portion we are above sea level? Velocity is positive, but do you see how the graph is decreasing? Acceleration is negative. For this portion, where are we? Above or below? We're below, so velocity is negative, but do you see how we're increasing? Acceleration is positive, okay? The other thing people come up with is, do you see how we're moving towards the x-axis? Speeding up would be going away from the x-axis. You're all looking and understanding this, like, very good. We're making eye contact. I like it. All right, so those 2 intervals, because velocity and acceleration are what? Are opposite signs there. And that reminds me, I need to say this. You can't just say they're opposite. It's opposite signs. If you don't put the signs, they will not give it to you. And this will be on the free response part. It is every single year. They always put it on there because it trips people up, and they're mean. All right, we'll do one more. This one would be a calculator one. While I'm typing it in the calculator, can you read that little paragraph there? I'm just asking you to read it. So what's the problem about? Hot air balloon moving upwards and downwards. Where does the hot air balloon start? It's initially where? On the ground. So can it start out by going down? No. If it's on the ground, I mean, a hot air balloon can't burrow into the ground. It's going to have to start by going up. Okay, perfect. What did they give us? Did they give us position, velocity, or acceleration? Gave us velocity, and our units are kilometers and hours. We all together? What we got out of that. Now, they also give you an interval from when to when. What's our interval? Okay, watch me do this. If they give you an interval, you have to make your graph go to that interval. Do you see this little wrench off to the side here? I'm going to click that. Do you see how my x is right now negative 10 to 10? I'm going to make it 0 to 4. Do you see how I did that? You have to do that, all right? Other thing, do you see how I changed the t's to x's? It won't graph it with t, so just change it to x, okay? So look, let's see what's going on. Balloon starts out by going up. Do you see how the graph is above sea level? Positive. Then it does what? Goes down for a little while, and then it goes back up. At the end of these 4 hours, should you exit the ride? It is not advisable. Why not? You're up in the air. Okay, unless you had a parachute, in which case that's all right. All right, let's read letter A. What does letter A say? For what intervals is the altitude decreasing? That would be where this graph is what? Negative, below sea level. I am so happy you guys get Desmos. Do you see how fast and easy that was for me to just click on those numbers? That is so complicated on the TI calculators, and I got it in 1 second. From this time to that time, we are below sea level. How many decimal points do you need? 3. All right. 1.571 hours to 3.514 hours. Does it say to explain it? No, but if it did, it would be because if you say it, they will not give it to you. I'm the messenger. Velocity is negative. You have to cite your source. It's either position, velocity, or acceleration. All right, letter B. Find r prime of 2. If you missed this on the test, look up here now. I have the function typed in, and I am literally just going to type r prime of 2. Do you see that? -4. Write it on your paper. R prime of 2 equals -4. Just got it from the calculator. Oh, for this? No, you can just put that to that. Or you can use the parentheses, or you can use brackets, whatever floats your boat. Yeah, that's fine too. Yep, that is all good. You can even use the little alligator mouth, the inequality symbols. You can do that. You can do whatever you want. All right, so we found that. It says explain the meaning in the context of the problem. Now listen, this is where this gets tricky. They gave us velocity and we did a derivative. So this is actually what? Acceleration. So we're going to say the rate is increasing or decreasing? Why is it decreasing? That's negative. The rate is decreasing for, and then what are the units for an acceleration? Well, this one's kilometers, but I got you. Per hour, and I would just put squared because I think it's shorter, but per hour. And then you have to say one other thing or they won't give it to you. At good time, what did we plug in? 2 hours. Perfect. Nice job. If you don't say the at whatever time, they won't give it to you. So rate is, oh, why did I not say decreasing -4? Yeah, that'd be like a double negative. Like the decreasing takes care of the fact that it's negative. All right, and then C and D will be nice and quick. When is the balloon closest to the ground? Well, look here. Where did it start? On the ground. Watch me point to this. This part, it goes up in the air. Is it closest to the ground? No, it's up in the air. Then for this negative portion, it moves down. So at this time, it would be closest to the ground because after that, it starts going back up again. So at 3.514 hours is when it's closest to the ground. Now, usually somebody is like, but hey, Miss Cole, isn't it closest to the ground when it's on the ground? Valid. When is it on the ground? At time 0. Why is that not the answer to this? It's not in the interval. Perfect. Good job, guys. Perfect. All right, making progress here. And then when are we at the maximum altitude? Well, it starts on the ground. And for all of this portion, it moves up. So this would be where it's when it's at its peak. So at the 1.571 time is when it is at the highest. Why would it not be at the very end? Like at the end of the interval at time 4, why would that not be the highest it gets? Because it already went down before it went back up again. So this is where it's going to be at its peak. Good. Common sense. I love it.